Moving forward in conic sections, now what we're going to talk about is we're going to talk about the circle. And we have worked with circles before, Algebra 2, we worked with them in geometry. And a lot of the information that we're going to get is going to come from the coordinate plane, of course, and then using different formulas. But let's look at our equation of a circle, and it is going to be x minus h squared plus y minus k squared equals r squared. And in the past, we have worked with the value or the variable h and k. So, and we know that, and we have experience with that h transforms our equation or our function horizontally left and right, and then k transforms it up and down vertically. And those things are going to be consistent with circle equations also. And we'll introduce r here in the equation, and we've seen a variable of r before too, but r is going to stand here for the radius. So that is going to be, and let's see here, the standard form. And the standard form we have here for the circle is going to be x squared plus y squared equals r squared. And looking at it as a transformation, it is, when we look at our transformation values, we have x minus 0 squared plus y minus 0 squared. And what that is showing you is that h and k are going to be my origin. So the standard circle is going to be, the origin is going to be at the origin. The center of the circle is going to be at the origin. And that's what we're going to work with going from here on out. And I have a little note over here, and it says if you identify the values of h, k, and r in each of the problems, then use the standard form to write the equation. So let's look at what is the equation here. So let's look at this first example. And what is the equation of a circle with a center of 5, -2, and a radius of 8? Well, remember our ordered pair is going to be hk, and our radius is going to be 8. So we know the center here is going to be hk. The center is also going to be 5, -2 with a radius r of 8. And then we can do our substitution. So we are going to be substituting in the value of h into our equation. Then we're going to substitute in the value of k into our equation. And then finally, we will substitute in the value of r into our equation and simplify. And so now our equation is simply going to be x minus 5 squared plus y plus 2 squared equals 64. So again, substituting in those values and then simplifying if necessary. And let's see here, as we go into translating to write an equation, it says, what is the equation for x squared plus y squared equals 1, translated 5 units, left 5 units, and down 3 units? And what I've done here is I've gone ahead and said, hey, left 5 units is going to be -5, down 3 units is going to be a -3. So as I put them into my equation, I go ahead and I graph my original equation. And if you notice here, I've gone in the standard form of the circle, and I have it centered at the origin with a radius of 1. And what it's doing is it's asking me to go ahead and translate left 5 units. So I went 1, 2, 3, 4, 5, and then asked me to go down 3 units, 1, 2, 3. So my new center is going to be at -5, -3, and of course my radius is going to be 1. So there I have translated the equation of a circle, or translated my circle. And then I know here that we went left 5 and we went down 3, and then when I simplified a negative and a negative, I get x plus 5 squared plus y plus 3 squared equals 1. And there is a translation. Let's see, remember translations too, that things remain the same shape. and size. So as we go forward into this next example, it's asking us to write the equation in for x squared plus y squared equals 9, translated right 2 units and up 3 units. And of course, right 2 units is going to be positive, and then up 3 units is going to also be positive, because that's the direction we're heading on the coordinate plane. And I do know, again, that my standard equation is going to be x squared plus y squared equals r squared. And we know that since they gave us 9, 9 equals r squared, or therefore r equals 3. So we can rewrite that as 3 squared right here. Looking also again at my standard equation right here, here's my standard equation that we just identified, and I'm going to be moving right 2 units. So there we go, I have replaced h with 2, and then it says I'm going to be moving down 3 units, so I've replaced k with 3. I'm sorry, we're going to be moving up 3 units. So I replaced k with 3. So remember, we have x minus h, so it was x minus 2 squared, plus we had y minus k, which turns into y minus 3 squared. So r remained the same, so r was 3, so that would be r squared. And rewriting it, here I have rewritten it. And let's see, the center has translated, but the radius is the same. So we started off at the origin with a radius of 3. And what I've done is I have moved right 1, 2, and I've moved up 3, 1, 2, 3, with the origin now at 2, 3. Starting to see that normal thing, origin at 2, 3, and a radius of 3. So there is my new translation. Okay, so continuing here, looking at using the graph to write an equation. What is the equation of a circle for a circular irrigation field that has a radius of 12 and a center here at 7, negative 10? And if I were going to be looking at a coordinate plane, and then it said a center is going to be 1, 2, 3, 4, 5, 6, 7, and then of course down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have that circle, the center of that circle down here at 7, negative 10. And it says, what is the equation of the circle for the irrigation with a field with a radius 12? So when we rewrite that, of course, see here we have x minus, well, replace h with 7 because it's a 7, and then that becomes x minus 7 squared, and then we have y minus a negative 10 because our k is negative 10. So when we replace y minus a negative 10, it becomes y plus 10 squared. And our radius is 12, and we know that our radius is going to be squared, which is going to be 144. And there you have it. So that is using the graph to write an equation. So the information that you need to write an equation, well, hopefully you have the center and the radius, because that is what you're going to need in order to create the rest of that equation. So as we continue here, finding the center of a radius, it asks us, what is the center and radius of the circle with this given formula? So I have x plus 8 squared plus y plus 3 squared equals 121. And I remember, of course, we're going to have x squared plus y squared equals r squared. So I can go ahead and replace the value. Well, let's see, let me change this, not this formula, but let's expand out that transformation. We have x minus something plus y minus something squared is going to be equal to something squared. So when they tell me that if it is x plus 8, then I know then that that should be x minus 8 because, or x minus a negative 8, because when I rewrite that, that would have given me the plus value. The same thing is going to go for my y value. If it says y plus, and of course we're going to be doing the opposite sign, and it's going to be y minus. And r, goodness, it tells me that, well, there's my r. R, what do I know? I know that r squared is going to be equal to 121, and I can find the square root of both of those, so r is going to be equal to 11. And I will just cheat at this moment. I will go ahead and just say 11 squared. So I know then that the center is going to be h, or my x value is negative 8, and my y value is negative 3, or the k value is negative 3. So there you go. My center is negative 3, negative 8, and I am going to maintain a radius of 11. And let's see, continuing on with some examples. We're going to have to remember how to use completing the square for circles, and that is probably the biggest use of completing the square that you encounter in algebra, is when we are trying to create equations for a circle. Okay, if you don't remember completing the square, you can go back and check out a video, and it's also in chapter 4. I think it's 4-8 in the textbook, but what we are doing is we are going to find out the information that we're going to need in order to complete the square. In this case, make it a perfect trinomial square, and we know that we have gone ahead and grouped like terms based on their variables, and I have y squared and 14y, and then I'm going to have x squared minus 6y, and I've grouped them together, as you can see right here. And what I'm going to do in order to complete the square, because I'm trying to create this perfect trinomial square right here, is I am going to take half of b, negative 6. Half of negative 6 is going to give me negative 3, and then I'm going to square it, which gives me 9. And that is a perfect trinomial square. This is x minus 3 squared. Then I'm going to do the same to the other side. I'm going to take half of b. b is 14. I'm going to take 7 and square it, which gives me a 49. And if I add something to this side, I'm going to have to add to this side. So I've added the 9 and the 49 to the original 8. And now we have 66. So I am going to take this perfect trinomial square right here and go ahead and put it in factored form. And that gives me y minus 3 squared. Starting to look familiar now to that translated formula. Plus y plus 7 squared equals 66. And now is the time when I'm going to go ahead and work on this and say, okay, well, this looks like a factor. This looks like a factor. And then we have simplified this radius. And then I get x minus 3 equals 2, y plus 7, x minus 3 squared plus y plus 4 squared is going to be the square root of 66 squared. And looking at that information, I should be able to say here that if I were to erase them, I can't erase that, but I can go ahead and write over it. This should be minus negative 7. So now I'm able to take k, which is negative 7, and put it in right here, and then h, which is 3, and put it in right here. And then the radius, of course, was going to be, let's see here, r squared is going to be equal to 66. And then if I found the square root of both of those, I get r equals the square root of 66. So there we go. We know that the radius is equal to square root of 66. And this would symbolize r squared. And then finally, our last example is going to be graphing the circle. And I know how much you guys love to graph. And graphing a circle using the radius. And we know that the standard form of an equation is x minus h squared plus y minus k squared equals r squared. So I'm looking here and I should see, well, h should be 4. So h should be equal to 4. And right here we have negative. Negative, that should be rewritten as y minus negative 2 squared. So we know then that that should be, k is actually going to be negative 2. So as we do our transformations here, and you can see over here on our graph that starting at the origin, it looks like we're going every 2, every 2, every 2. And so as I look for my origin of 4, negative 2, that would be 2, 4, and then negative 2. So that'd be 4, negative 2. And then I'm going to go from that point, and I'm going to go with a radius of 7. And doing so, I should be able to, since this is 7, this is 7, 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7. So I'm creating these points that I can go ahead and just, I can connect if necessary. Maybe you turn around and get one more halfway so you can get that transformation if you need it. And that is going to be the end of circles, and we are going to now do some practice.